Hey everyone, this is Sprint 192's review for the migration toolkit. Let me go ahead and share my screen here. Everyone can see my screen?
Yes.
Thank you. So this sprint ran from 10:26 to 11:13. We have the usual links here. Here's the planning document up top. And we'll get started right away because I think we've got a pretty stacked agenda today. Fabien, do you want to go ahead with MTV?
Yeah, thank you, Eric. The first demo is actually an end-to-end demo we recorded a few weeks ago now, but still in the sprint. Let me share my screen. It's actually available on YouTube. And but might be better to start it from here. Just do you hear the sound of the video?
I'm not getting any sound.
No.
But I do see.
Okay. But if you can see it, I'll just do the voiceover in live. So it's a demo of migration toolkit for virtualization based on Konveyor. Here we have already installed the operator, and we start by adding a provider. It's a VMware one. Quickly, we can see that the inventory is working. We pulled all the information about the clusters, host, VMs. We can now create a migration plan. We call it demo. As a source, we select the provider we just created. As a destination, we have by default a provider connected to the OpenShift cluster where the operator is deployed. We can select VMs from a list of folders or directly from the host. Here, my VMs are named after me, so fdupont-something. I picked just two, one Windows, one Linux. And I can then map the storage and the network to their destinations. So the list of storage and networks on the left is actually the list of storage and networks connected to the VMs. Not all the networks and storages of the cluster, so it's really limited to what you want to migrate at that time. Here, our plan is created and started, and we can see that we have information about the different steps. So only 2 steps now because it's fairly simple. And you can see that in a few minutes, the migration was done. If we go into the virtualization UI of OpenShift, which is the standard one, we can see the 2 VMs and start them. And we can even access the console. So here we've got a Windows. We are Red Hat, so basically showing you that the Red Hat works, a rel VM works is not very fair. So showing you Windows 1 seemed a bit more challenging. And that's it for the demo. Most of the changes after that in the sprint were done in the UI or hidden in the backend. So I'll hand over to Mike for live demo on the UI changes.
Thanks, Fabien. Let me share my screen here in a moment. All right, can you guys see the UI welcome screen?
Yeah. Yes.
Okay. So I'm going to show a few new features we have in the UI here. Mainly, we finished working on the CRUD operations for providers and mappings and plans. So you can now edit and delete them. And I'll show a few other things as well. So first of all, I'll start on the providers page here. I've created a fake provider that doesn't really work, but I can show editing and deleting it. So when you edit a provider now, because when you create a provider, there are fields for credentials, and we can't fetch those values and pre-fill them because they're secrets. So instead of showing the fields empty, there's a checkbox to choose whether or not you want to replace them. So if I leave this unchecked and I change this to some other URL and hit save, it won't touch the secret at all. It will just change that URL, and you can see that it changed in the list. But if I check that box, it will ask me for a new SA token for OpenShift, or if I'm editing a VMware provider, it will ask me for a new username, password, and fingerprint. And then if that is included and filled out, it will update the secret as well as the provider CR itself. While I'm in here, I can show some form validation enhancements that we've made. So if I go to create a new provider, this field, the name field used to just assert that it's a string. Now it will assert that it's a valid Kubernetes name. So if I start typing, that's valid, but if I put a capital letter in it, it will tell me the name can only contain lowercase alphanumeric characters and dashes and must start and end with an alphanumeric character. And that's in place for a lot of other fields where we have specific requirements now. You know, this for OpenShift, this has to be a valid URL as well. So we've made sure that all these inputs are going to be valid rather than waiting until we get an API error to show the user. One other thing I wanted to show, well, actually, let me do the rest of these CRUD operations. So if I delete this provider, it will prompt me, do you sure you want to delete this? Let remove, and it is immediately removed. So this is removing the CR, and then the inventory API catches up. Excuse me. So I can also show editing and deleting mappings. If I go to edit here, it loads all of the existing stuff and pre-fills it for me. I can add mapping items. I can save. Here's the source. Save. We'll update. You can see that new item. And I can delete. Not very exciting, but it rounds out the ability to manage these CRs. Same thing for plans. Now, plans are a little more involved. First of all, you can't edit a plan that is has been started, and you can't delete a plan that is running. So I can edit this plan because it hasn't been started, and that loads the plan wizard. And there are a few differences in logic here. If I step through, it will select the filtered VMs, the tree items that filter the VMs based on an assumption of the VMs you have selected. So when we save the plan CR, this selection of these filters is not saved, but we want to, based on the VMs they've selected, you know, when they proceed to this step, we want to already show them a list that includes what they've selected. So it goes through and selects the tree items that match, minimally match what the VMs they've selected are. I can step through here and change the VMs that have been selected, or if I change this tree view, and some of them are still selected, it will still show them. So it doesn't clear the values from the wizard like it used to. Excuse me. So if I go through here a little bit, you can notice that since I've added some VMs, the mapping now requires some additional sources. So they've been added here. I've got the existing mapping that I had, but now it's asking, hey, you need to, because you're editing and you're adding VMs, you need to map these additional items. And because I changed it, it gives me another opportunity to save it here. But if I go back and I remove those additional VMs, it will go back to the mapping I had before. So let me proceed with that. Select some new mapping targets. Same thing for storage mappings. And I've got my results here, so I can see, let me go back and change something. Well, I've added VMs, so I can demonstrate that there's some things changed, and then I will finish, and it's been saved. If I go in here, you can see the additional 2 VMs here. And then once again, I can go ahead and delete that plan. So that's just the demonstration of editing and deleting. You can manage all your CRs easily now. One other feature we've added is because networks in OpenShift, network attachment definitions, can exist in multiple namespaces. Technically, it's not a common use case, but and they can have the same name in more than one namespace. So we've now namespaced these. You can see what namespace the networks are in as a prefix here, just in case you have a duplicate, like I show here. Another little detail that I wanted to show is that if you have a failed plan, we now have detailed error messaging in the progress view for the pipeline. So just a bunch of little things here. One last thing I want to show is that for VMware providers, we now have wired up the inventory payload API, so you can download your payload JSON bundle that you would upload to Migration Analytics, which Peter will show after I'm done here. So I can just select this VMware provider, click Download Data. It runs over here and downloads that file. I can show, if I open my file manager and extract it, we get some JSON out. So everything's working end to end. Pretty much feature complete, just time for bug fixing and making this nice and rock solid for beta. And that's all I have to demonstrate.
Awesome.
Thank you, Mike. Any question for Mike? Well, that last one part of the demo is actually a really good transition for Peter, who wants to demo how to upload the inventory payload file to Migration Analytics. Peter?
Thanks, Fabien. Are you able to play the video that's in? It's linked to
Yeah, I can.
Sprint Review Doc. Thank you. Can you make it any bigger?
Yeah, I can. I can also probably force. And
great, thank you. Okay, so this is just showing the inventory payload pod running on my cluster. It's got its own route. So I'll go to that route. So this is doing behind the scenes what Mike just demonstrated from the UI. Going to the API endpoint, we pass in a list of providers that we want to extract, and that downloads the same file that Mike showed. What we can now do is go up to Migration Analytics in cloud.redout.com and upload the target GZ file. And create a report. Now this is Migration Analytics version 1 compatible Migration Analytics website. So if we look at that report, what we see now in the migration summary is all of the new flags that we're identifying. So we're showing that 36 VMs have high availability detected. Some of these mean that they're running on a cluster or a VM that has the flag applied to the cluster itself. So we're propagating that down. So we're identifying all the flags now. We pull out the operating system information in all of the VMs. And if we go to the migration inventory, we can expand each individual VM to see the VM configuration and what flags are applicable to that VM. And just look at one more. So this is Jeff's VM has a shared disk presented to it. So there we can see we got 4 flags applicable to that VM. And that's the end of that demo. Thank you.
thank you, Peter. So it was really the link between the UI and what it brings in the cloud. The last demo is actually not related to that, but more to the work we're doing on warm migration. So warm migration is actually allowing us to migrate a VM while it's still running on the source provider. So it targets at limiting the amount of downtime for the VM during the migration. So in that work, Matthew is actually implementing incremental copy based on snapshots. Do you want me to run the video and you do the voiceover, Matthew?
Let me try to play the video myself.
Okay.
Just so I can pause it.
Sure.
Is that showing up?
Yes.
Okay, good. Right, so what I've got to show today is kind of a standalone incremental copy. It's not running inside the KubeVirt environment, right, or CNV. It's going to be transplanted into that environment in the coming sprint. But what we've got today is a successful Delta copy. So at the beginning of this demo, I've got two disk images pre-downloaded, so the base image, the Emerald MTV, and a snapshot image. And what I'm going to do is have it connect to VMware, download the changed blocks between the two, and apply all those change blocks to the base image. At the end, we're going to get a temporary image that should match the snapshot. We'll just let this run and see what it kind of looks like. We're connecting the disk. All right, and so what we see here is it's running through the list of changed areas reported by VMware. One interesting bit of knowledge from IMS is blocks that are around 1 megabyte are not really worth asking for status on, like to see if they're all zeros or anything. It's faster to just copy them. And you can also see blocks that are bigger than 1 megabyte. We check to see if there's any zero or holes in them, so we can do a quick write of zeros instead of copying the whole thing over. Speeds things up a little bit. And there we go. We've copied all the blocks in, and just as a quick sanity check, an MD5 sum of all the images in the directory. Very suspenseful. So what we can see is the final disk image there has that MD5 sum, and the final temporary image matches the snapshot, and that's all the blocks, change blocks applied to the base image, and that's what we're going to be rolling up into CNV soon. So that's it from me.
Thank you, Matthew. The other part is actually doing creating the flow in the VM import operator, and Sam is working on it, but nothing worse to show even from a command line point of view. So probably at the end of the next sprint. Any question for MTV this week? Well, then I think at the end for MTV, I hand over to you, Eric.
Thanks, Fabien. So the last sprint for MTC was largely a push for our 1.4.0 feature complete. So the 1.4.0 release, we have a link for a lot of the JIRAs in the document, but the basic story for this release is basically it's overall improvements to kind of hardening the product so that we're ready for a lot of larger scale production migrations that we expect to be happening in the first quarter of next year. So along those lines, I'll pass it over to Dylan to show our direct migration, which is a really great feature that we've added.
Thank you. Let me go ahead and share my screen. Hopefully this turns out okay. Thank you. So this is the direct migration feature. So last sprint, me and Scott both demonstrated driving this directly from the API, where we are connecting the source and target cluster and directly migrating the image data. So anything in the internal registry, and then any persistent volume data that where the existing file system copy using rsync, we're replacing using rsync to go directly from the source to the target. So this sprint, we did a lot of work to integrate this into the existing MIG migration controller, which enables this from the UI. So this demo here, we're currently on an OpenShift 4.6 cluster where the controller is running. So this is our host and target. And then we're going to go ahead and add an OpenShift 3.11 cluster as our remote cluster, which is going to be the source. And you'll see that when we do this, there's a new field in the cluster addition page here where you can actually include the exposed route to the image registry for a remote cluster. So just like you do in the past, you're still going to add the service count token for the remote cluster, but then you can optionally, if you want to enable direct migration of images, all that's required is we need the route of the internal registry, and it needs to be exposed. So on OpenShift 3.11, this is going to be the Docker registry service in the default namespace. So you can see here is the tooltip on what to add here. The obvious benefit here is you're going to get a massive performance improvement here. So the existing workflow was essentially a two-step migration where we were taking the internal images on the source cluster, backing up the data into the replication repository, and then at restore time, pulling the image data back out of the backup storage location and putting it onto the cluster. So you had 10 gigabytes of images, you're really copying 20 gigs over the wire, which was a big inefficiency there. So that is the new addition to the mid-cluster edition page. Now if we actually go to the migration plan, this will all look pretty much the same. But actually, let me quickly show you the application itself. So we're using a source to image app, which is a Django front end and then a Postgres back end. So the database is storing the page count. The reason why I chose this app is because since it's source to image, we're actually migrating the image stream, which will carry over the internal image using direct image migration. And then we've got one persistent volume that we're going to do the direct PV bits from. So back to the MIG plan screen. This will all look pretty much the same up until step 4. So we're going to add our source on our cluster, select our namespace, which is Django. You can see it's got one PV. And then now with MTC 1.4 and above, if you select file system copy, you have enabled direct migration, which is the default, which you'll see on page 5. We will default to using this rsync workflow as opposed to rustic. So you can see I am selecting file system copy like you would have done in the past, which would have taken the whole stage pod approach and used rustic. I'm going to keep that option and go to next. And then page 5 here is where we can actually optionally disable or enable the direct migration bits. So you can see by default they're both checked. I'm going to leave them checked because I want direct image migration and direct PV migration. No hooks for this case. And with the MIG plan validated, we can go ahead and start the migration. So the open UI changes that need to happen here is really real-time progress reporting from the direct migration work. So since we don't have that just yet, and Alay is going to demonstrate some of the progress reporting work we've done next, I wanted to just show you some values on the MIG migration CR that can give you an insight into what's the state of the direct migration work. So with this migration, just based on the available PVs and the selected options, we're actually going to be able to skip entirely the stage backup and restore portion of the migration. So that's a huge performance enhancement in of itself because there's a lot of steps we can skip. But you actually see here there's 2 new steps that were added onto the MIG migration CR. One's called direct image, one's called direct volume. And then they're actually going to store some set of progress and state. So we'll keep an eye on this as the migration runs. But you can see right now it's still going through the pre-backup hooks, just as it would in the past. I don't know if you guys can hear my cat screaming through my door right now. But so that image I just showed was that resource there. There's 2 new resources. We have the direct volume migration and the direct image migration custom resources. These resources are actually what is in a separate control loop migrating the images and persistent volumes directly to from the source to the target. The difference with this new workflow is that they kind of are able to run in the background to an extent. So the images that are being migrated in this case, as soon as we create the initial backup, we automatically start the image migration. We don't have to wait for Valero to finish for that to function. It allows something. Volume migration is also running even while the MIG migration controller is continuing through its other steps that it needs to take. So what's actually happening in this case, which you saw in the last sprint, we're standing up an rsync daemon pod on the destination for each namespace being migrated. And then on the source, we're standing up a set of rsync client pods. And they're actually migrating the persistent volume data directly to the destination cluster. So looking back at the big migration CR, we're back on the final restore already. The direct volume migration resource has completed. You can see it's in a succeeded state. It shows the client pods that ran on the source cluster. And if we actually take a look again at the big migration CR, you'll see that the progress of direct volume shows 1 out of 1 volume migrations were successful. Then the direct image migration was successful as well. So the migration itself has succeeded. We can now go and confirm that the application on the source has been quiesced and that the application is now currently running on the destination cluster. And if we remember the page count of the application, it was at 170 something, I think. High 160s, low 170s. But you can see this is on the destination cluster. Pods are coming up since the source to image is still deploying and deploying Postgres, but it looks like Postgres is up. Check again, the Django app is up. So let's go ahead and take a look. This is the original app. The page view count was at 171. So we refresh it, prove it's quiesced. And if we refresh the new app on the 4 cluster, this should show 172, the page count, if the persistent volume data was copied correctly. It does. So, yep, that is the direct migration driven from the UI. The one last thing I just want to call out was, so from start to finish, this migration took 2 minutes, 45 seconds. If we deselected those checkboxes on step 5 in the MIG plan and opted to use the indirect migration for both images and volumes, for the same app, it took just about 6 minutes. So we've cut the migration time in half with this app, and obviously the performance enhancements only get better with the more image and persistent volume data that's actually being copied. So that is the direct migration work. Scott was the big driver of the direct image migration work. So if you have any questions about that, I'm sure he'd be happy to answer. That's all I have, unless there's any questions.
Yes, I have a question. Well, I saw that when you added the migration cluster, you configure the internal registry too.
I'm sorry. Can you repeat the question?
Yes, sorry. When you added the cluster, so we have the internal registry.
I don't know. Is it just me, or is anyone else having trouble hearing you?
Yeah, I was about to say if anybody could get a better line on it because I was having trouble. He was cutting out as well.
I think I understand the question.
I'm having a hard time hearing too, but yeah.
Yeah, I think the question was pretty
Tom.
much about when we added in the source cluster, you had to add in the image registry. So probably just clarifying what are the requirements and
Sure.
what's needed around that.
Yeah, I can answer that. So basically, the change here is that when we did this through Valero, the only time we ever accessed the registry was actually running within a plugin on the cluster, so it was local. So we were able to use the internal service for the registry, because by default the registry is not exposed outside the cluster. There's no route created for it by default. So in order to use this, any remote cluster, whether it's source or destination, needs to have the registry exposed first. So basically, in a default environment where there's no additional customer-specific firewalls in place, basically it's just a question of running OC create root pass-through, passing in the internal registry service in port 5000. Once you do that, you have a externally exposed route. So it's a so basically you have a route on port 443, which then points to port 5000 on the internal registry. Once you have that host name gets passed in the create page for the remote cluster.
Okay, and when I add this internal registry, imagine that I need to authenticate myself, that I have to provide the user credentials.
Yeah, the credentials are the same. Since it's just a pass-through route, the credentials that the controller passes to the registry are the same as it would pass to an internal one. Well, because we already have a token that when you add a cluster, you add that token. That token has is used to authenticate with the registry. Because the token we're using, the credentials we're using, have permissions to access images.
Okay, so the token will be the same.
Yes.
Okay, yeah, that was my question. Thank you very much.
Hey, Scott, do you have any problem handling images that are referenced by SHA and manifest lists? Because if I remember correctly, the internal registry does not handle manifest lists.
I'm not sure about manifest list. I mean, basically, what I know what we're doing right now basically is going through the for every image stream in the namespaces we're migrating, we iterate over the list of tags instead of status tags, and they're that list of SHA's tags for each image that's of concern. So anything that's internal, we basically use the container's image package, which is the backend behind Scopio as well, to make the copy. And I guess another point here too, just for kind of background, this isn't new functionality. This is kind of reconfigured. Everything we're doing to copy images from the controller, this new controller, it's basically the same logic and the same Go code that we have used since the first release of this within a Valero plugin. So this is kind of moving code around to access it in a new way, because now we're copying directly from the source to the destination. In the Valero plugin, what we did was copied from the source to this internal, this temporary registry that's on S3, and then on the restore, we copied from that S3 back to registry to the destination. So this is kind of, which is to say that anything that worked before the customers are using is still going to work. If there's a use case that failed via Valero, probably not going to be any better now.
Scott, can I ask a question about this
Sure.
feature? It looks great, and I'm just wondering, why is it an option? Is there any scenario in which the customer would not want to use this?
Basically, the only scenario would be if a customer had some policy or concern about exposing their internal registry. Maybe they have proprietary images that they feel they don't want to expose outside the cluster at all. And in that case, they would still use the old way of doing it. But because, like you said, we think most customers will want to use this, that is the default now. And basically, as long as they provided that exposed registry route for all of the remote clusters involved, then using this will be the default workflow. That checkbox on the screen that Dylan showed is checked by default, unless a cluster doesn't. If a user doesn't add that route when they add the cluster, then we'll uncheck this and not use it. But it is the default workflow.
Okay, and the route is optional, not mandatory?
Right, because it's optional in the sense that if they don't add it, then we have to use the kind of previous way of doing it through Valero with the two-step copy.
Understood. But if they want to use the direct copy, will they understand that they need to add the route?
They need. I mean, this is one of these things that, again, we need to be kind of clear on the tooltips and the documentation. Because basically, I guess the point is, if you want to use direct copy, then it is required that you add the route.
Yeah. I'll just jump in and mention on that UI page, the mid-cluster edition page, if you hit that little question mark help box, it explicitly mentions if you want to support direct copy, you must fill in this field.
Ah, excellent. Good. Thanks.
Any other questions?
When we are going to decide if we want a direct copy or not, we already know if we have configured the road, isn't it? So if we don't have the road, we can disable this option. Is it possible?
That's the UI. I believe the UI has logic for that. Basically, on that page where you select where the checkbox is there, if that route is not specified for either the source or the destination cluster, if it's remote, I mean, we don't need it for the local cluster. So for example, if you're running your controller on the destination, which is the default setup, then you don't need it for that. But if your source cluster does not have it specified when they added the cluster, then the checkbox will be grayed out and it will be unselected, because if you don't have that set, then it's impossible to do. And if you're using the API and you're directly creating this and you specify direct image copy, but you don't specify the route, then we have a validation that complains even before we try it, that's not a valid combination. So at the API level, we have validation that will make the cluster or the plan non-ready. But from a UI point of view, we don't even let you pick it. Prerequisites.
Oh, okay, perfect. Thank you very much.
Any other questions before we move on? Okay, up next, along the same lines, as Dylan mentioned, with direct copy for both image migration and for PV migration, we also have been working pretty significantly on a lot more visibility into progress reporting on what's going on and how far along am I, and answering questions like, am I stalled, that sort of stuff. So Vince had shown off some mocks that displayed kind of a UX, some UX changes in that area, and that's kind of the last lagging piece for 1.4.0 that we're continuing to work on. We expect to come together in the next week is implementation of the UI around this for direct migration, but Alay can jump in and show some of the progress that we've made on the underlying plumbing that provides that information for rsync.
Sure, I'll just share my screen. Can you see my terminal?
Looks good.
Okay. Yeah. So this is related to the direct volume migration that was just demoed. The objective here is we want to show progress reporting for direct volume migration. The granularity we want to go to is per PV transfer. So if you have 10 PVs, you'd want to see progress of each one of those PVs. Just a small implementation detail to catch up from the direct volume migration controller is that it installs a rsync daemon on the destination and runs the rsync client pod on the source. Because it runs rsync client pod on the source, the information of progress is in the source cluster in the pod which runs the rsync client. Because this is run on the source, we don't really have a watch mechanism on the source side, because in 1.4 we removed remote watches to get memory performance improvements. Because we don't have watch, we need to poll for the state of the rsync client pods, and it is possible if the polling level is not small enough, it is possible to miss those updates. Hence, for 1.4.0, we narrowed down the objective to show progress reporting for the rsync client pod that was stalled for a longer period of time, as in few hundreds of seconds or in order of few minutes. So with that, I'll dive a little deep into the implementation detail. We chose to introduce a new CR, Direct Volume Migration Progress, so that we can abstract out implementation details from the direct volume migration. There are quite a few implementation quirks on the direct volume migration progress. For instance, we have to decide on the polling interval. We have to decide on the parsing logic of the rsync client pod. We have to decide on sharing or reusing the network connection for getting the logs each time we make a poll, right? So those are the implementation details that are hidden under the new controller, Direct Volume Migration Progress, and it's abstracted out of the Direct Volume Migration controller. The Direct Volume Migration Progress has 3 important fields: the log message, which contains the last 5 lines of the rsync client pod logs, the last observed progress percent. It is the progress percent that was parsed from the rsync client pod if available, and the last observed transfer rate. It was the last observed transfer rate available on the rsync logs. With that, I'm going to show all of those three fields in the demo. On the left column terminal, I have the controller running. On the right top, we have the DVMCR status. And on the right bottom, we have the DirectVolumeMigrationProgress CR status. I'm going to watch all of them as the migration starts. In interest of time, I have recorded the demo halfway through, so this is actually waiting for the rsync transfer pod to be running on the destination. It should be fairly quick. And that is done. Now we are installing certificates and creating client-side resources. As you can see on the bottom right terminal, the spec includes pod reference and the cluster reference. So we have source cluster and the pod reference. The pod is right now not created, and there you see now the pod just being created. You can see now that the log message, it has last 5 lines of the progress. Because those last 5 lines do not have a progress percent and a transfer rate yet, it's not available in the status. A note here is that rsync does not always present the transfer rate and upload percent. It only does that when it is actually uploaded. It has successfully uploaded a file from source to destination. Right now, the last 5 lines do not indicate any successful upload. The very first file in this source PV is a 1 gigabyte file, so it will actually take few seconds to complete. And until that is done, we will not get any progress information. Once that is done, we expect other smaller files to process relatively quickly, and we should see updates much quicker in that 5-second poll. As you can see on the DVMCR, we have a field that lists the running pods. For all running pods, we will have the progress percent and transfer rate. That suffices our objectives. As you can see, after the first file that was large uploaded, as we expected, other updates were significantly faster. You can see in the last 5 lines, we have the amount of data copied. Most of this 1.3 GB is from the first larger file, the progress percent, the transfer rate, and then other fields on the rsync logs. You can see that the last observed percent is cascaded into the DVMCR. And then we get 100% success. So that demos the progress percent parsing in DVMPCR and bubbling up to DVMCR. The next step for this is to bubble up this information in the UI via the MIG migration. So we have progress percent for all stalled pods. Also, one thing to note is since the progress percent and transfer rate is not always available, if it is not available, the user can always check out the last 5 lines in the log message to see where they are stalled at. And one of the next steps is to also figure out a way to display this message in the UI. So that concludes the work done in the sprint. If there are any questions regarding this, I'll be happy to answer.
Doesn't sound like we've got any. Alay, we have you up next as well for the partial failure one.
Sure. You should be able to see the partial failure video as well. Okay. Thank you. Yeah. So yeah, the objective here was that Volero operations, backup and restore, can sometimes generate partial failures. Up till this point in time, the current state of the world is that partial failures are considered as failed attempts of MIG migration. So once you hit the final partial failure on any of backup or restore operations in our itinerary, it would drive the migration to a failed state. What we wanted to do here is to continue running that migration until completion, and then display those warnings, display the final partial failures as as warnings on the MIG migration, so that a user can decide whether they want to call this migration failed or not. Sometimes it is possible that Volero calls out an operation partial failure for resources that a user doesn't really care about. So even if it is partially failed, they might consider that as a success. So I have a recording, but since we have a packed agenda, I'm going to skip to the part which generates the partial failure. In this recording, I am using a QE test case that is supposed to fail. It will generate a partial failure in the final restore, and I have skipped to the pipeline view where final restore is created, and we'll wait for that failure. You can see in the pipeline view that our restore has partially failed. You can see the name and namespace. We will scroll up on the MIG migration CR. You can see there is a warning that is added in this work, which explicitly gives the namespace and name of the Volero restore that failed and on which cluster. So it says partially failed on the destination cluster. This will enable the user to go check out Volero logs and figure out what objects failed, whether or not they care about those objects or not.
Alay?
Sure.
I had a question on that. Is there something that we could do in the future where we'd be able to run those queries ourselves, get the info, and then display that?
The Volero logs query?
Yeah, pretty much. The end goal I'd like us to get to would be to display a message here saying that we could not restore food because of XYZ. Instead of just being the actual restore that failed, but if we can get to the exact error. And
Sure.
I'm assuming that error would be in, I guess, the Volero logs that are on object storage.
Yes, I can get to that part. That is one of the future goals we have for this entire Jira.
It started as like kind of an improvement, and there's a three-phased approach, and that I think, Alay, you can correct me if I'm wrong, but I think that requires some Volero upstream changes, right?
Yep.
Yes.
Yeah, we talked about doing that, and then there will be some caveats around that, like some probably going to be only limited to a certain number of errors. So if there's 6,000 errors, you're going to have to go look at the Volero logs. But other than that, that is on the plan. We talked about doing that with some upstream work.
If we didn't do any upstream work, would we be able to just simulate what Volero does in the CLI tool?
We could. I think that was one of the options we've considered. We'd have to build basically some equivalent of the download requesting on our side. I think we figured out that might actually be more work than the upstream work, but we have a kind of list of options we've talked about, and that's one of the ones that we considered. But I think we're leaning towards doing the upstream work. But it's an ongoing discussion.
Yes, it is actually one of the next. It is one of the tasks in the next sprint is to figure out how we bubble up this information from Bolero into CAM.
Yeah, and also I think we've even started that discussion upstream. I think one of the recent meetings. I think the next step for that is to just come up with a design proposal for pulling that out.
Cool. Just the takeaway is, if there's any way for us to get this into 1.4, I think this would be a really big thing for customers, where if we could find info and then put it on here, opposed to kind of kicking it to them to run another Valero command.
Sure. At this point, I'm not sure if we would be able to make it in 1.4.
Let's talk about it later more.
Yep. Sure. I would also one more point here. I think this example, the fact that we're able to find the QE example to use here, I think is a reason why we're making this change. Here's an example where any migration that includes this particular combination of images will always fail. So our only chance at a successful migration until we fix the upstream bugs that this relates to is for this to work, and then the user can figure out, okay, we'll have to copy these manually. But this is kind of an illustration of why we want this not to fail in migration always.
Yep. Yeah, and just to wrap up really quickly here, the migration will complete as up till the final step, and the final step will, as you can see in the UI, it shows completed with warnings, and we have plans on showing up what warning messages are in the CI, in the CLI on the UI, so that user has more information to start with. But that wraps up the demo. The future work we have left pending here is the UI can show up the warnings as it hit. So let's say we are in the initial backup and we hit a warning that it partially failed. It would be helpful that the UI shows this warning as soon as possible, and so the user can decide there itself if they want to fail the migration or if they want to continue. So that's one improvement. The other improvement was, as John was suggesting, if there is any way to show this information of what actually failed from Valero into the MIG migration, that's another big bucket of work that is for the future work on this item. Yeah, that's it for my demo. If there are any more questions, I can answer them.
Thank you, Alay. Next up, along the same kind of story of just additional visibility into what's going on. During Sprint 191, we added quite a bit of events and better logging information, so that when you read a log, we've got a lot more information about what's been going on, and especially you can track the progress and what's been happening over time. And so that was rolled out to one of the controllers. So we had kind of a pattern that was established in 191, and we've been applying that to some of the other critical controllers. So that's been added to across MTC. Shubham, I believe you're up next.
Yeah, so let me know if my screen is not visible.
I can see your screen, but the video is a little small. You might just need to probably click on it and full screen it. Okay. Looks good.
Okay. So today's demo is regarding logging improvements done for MTC controllers for MTC 1.4, and some background and motivation regarding this. So our MIG operator introduces some custom resources like MIG plan, MIG migration, MIG hooks. And these CRs are associated with some conditions, but the conditions are quite transient. Like CR gets updated from healthy state to unhealthy state and juggles from state to state. So the logging messages currently are quite general and constant. They do not provide a lot of context regarding what is going on under the hood. So regarding the implementation details, what we did was to overcome these shortcomings, like three things. We logged the condition on the CR at the end of each reconcile loop. Then we enhanced the logging statements by addition of some context or the subject on which the action is being performed. And these improvements are done for all the MTC controllers right now. It was done only for mixed storage in the past sprint, but the same pattern is being followed for all the controllers now. So in order to like the outcome of these improvements is that the logging improvements will enable us to construct a timeline of the events that took place during the migration, and this would make the process more transparent. It also help the developer or support engineer in debugging and fast identification of the root cause for the issues which occur during migrations. So for demonstration purposes, we'll be going through scenario logs. Like we have, for example, if we have some logs gathered and we want to construct a timeline of what happened. So we have the logs of the CAM container, and what I'm doing is just doing a grep on migration string. So here we can see that for the CR mentioned here is migration. The CR can be plan, the CR can be cluster, CR can be hook or storage. And we see the corresponding conditions being logged. For each condition, we specify, we show the type, status, and the message being associated with the condition so that we get more context. So here we can see that the migration is in ready status, and the conditions are logged after each reconcile done by the controller. So if we move ahead in the logs, we can see that there is a change of phase for the migration. Now we're still in the wait for refresh phase, change to clean stale annotations phase, and similarly going ahead we are in restart Velero phase now, but no change in the conditions of CR. So still we are having the same conditions. So now we have reached the wait for registries phase, and if we check now, the conditions are similar, but now we see a new condition of registries being unhealthy, and the message associated with the registries showcases the pod which is unhealthy. So as a developer, this gives me a context on what is happening, and so I know that something is wrong with the registry container. So I check up on the container and I see that there is a network issue associated with it, and after identifying the root cause and solving the problem, the logs will be updated, and this enables us to see what kind of conditions did the migration go through. So now we can see that the problem was resolved and registries became healthy, and the migration is ready and it completed its course. So in this way, we were able to like give more transparency to the developer, the user. And I think this concludes the demo. Let me know if there are any questions associated.
Well, one thing I would like to call out here is, along with those logging things, we also added events. So any log message you see, you can see a related cube event. And so if the pod is restarted and the log is not available, you can do an OC get events -n OpenShift migration, and you should be able to see a similar information in that as well. So we have backed this with like fallback as well.
Thanks, guys. Up next, we have Pranav, who's going to be showing progress on the progress reporting.
Well, can you guys see my screen?
Looks good.
All right. Dylan and Alay already demoed a little sneak peek into the new pipeline view in the CLI. In this demo, we'll be looking at the UI side. Get started. Here I already have a MIG plan created. I'm using an app which has about 2 PVCs and 500 cube resources on the source cluster. Each of these PVCs has about 1 gig of data. We'll try to migrate this app. Go ahead and hit the migrate button. Yeah, as you can see here, when I click the link, we go to a new details page where in the status field we see the new pipeline view. Until now, we used to show one big progress bar per migration, and in that, the description of the progress bar would be what the name of the phase of migration we are in. This improves that experience and implements what we call as a pipeline, in that the migration is divided into high-level steps. And instead of just showing the name of the phase we are in, we are now in the new pipeline view, we now show the human readable description of what work controller is doing in the background. As you can see here, we are in the prepare step where the controller is waiting for refresh of MIG plan and all these resources. Then we move forward to deleting leftover annotations. I'm just going to skip through the prepare step and go to the backup step. Backup step is where we create a Valero backup of cube resources. And as you can see on the right side, we now show detailed progress of the ongoing Valero backup as a progress bar. Once the backup's complete, we move on to the next step, stage backup, where we create Valero backups of volumes. Since we can have more than one volumes associated with a MIG plan, we don't have a consolidated progress bar in this view. Instead, we have a view details button. In that, when you click view details, you go to one level below and you see the actual volumes and the progress of the ongoing volume backup. Next up is the stage restore, where we restore the volumes we backed up on the destination cluster. We do have a similar view for stage restore, where we show the progress of ongoing volume restore, but we don't currently have the progress of Valero restore. We just have it for volumes because Valero doesn't support it at this point. We do have a design docs submitted upstream, and we should be able to get that feature in pretty soon. Yeah, so this currently only shows whether the restore is in progress. It doesn't give you the detailed progress information because it's not supported. But the backup and the pod volume backup and the pod volume restores are all supported. We will have a similar progress bar implementation for DIM, the direct migration stuff as well. And with that, this migration is finished. That's all I had.
Thanks, Pranav. It looked like you might have another video.
That was Jaydip. Is he in the call?
Yeah, I am in the call.
Great. Do you want to take it away with, it looks like it's the annotation label and hook progress?
Yes, I'm gonna present. Can you guys see my screen?
I think so, yeah. I see the document right now.
Yeah.
Oh, let me just share it once more. Do you guys see the video now?
Yep, it's full screened with the console on the left.
Yeah, sure. That's it. So this demo is around the work done on progress reporting for stage for hooks and annotation resources. So right now I have a migration running with about 10 namespaces, pre-backup hook configured, and about 20 pods. So in the interest of time, I'm gonna skip to the phase where the hooks are running. So as we can see over here, we will get the name of the hook that is running right now and the status of the hook in terms of whether it is running, whether it is failed, or whether it is succeeded or not after the phase is completed. So let me skip ahead a little bit. So we can see over here that we can see over here that after the phase is complete, the status of that job is changed to succeeded. And let me skip ahead till the annotation and resource phase is running. So initially, annotation and resource phase was a long-running phase with a single reconcile where we didn't get any update in between. But right now, it is broken down to multiple reconcile, and we'll get a fixed amount. We'll get an update after a fixed amount of resources are processed, so that no end user don't have to stay there and wonder that whether this phase is making any progress or not. So right now, as you can see over here, that 8 out of 16 pods are annotated, then now 14 out of 16. So in the PR, the number is 50. So after every 50 resource gets processed, we'll get an update. But right now, I have kept that number as 5 for the demo purposes. And that's about it. These were the two main phases that I worked on this sprint for in regards to progress reporting. Let me know if you guys have any question.
Thanks. Up next, switching gears, we have Sean, who's going to be showing off some progress into our namespaced Valero POC. So the background with this is, as everyone's aware, we were looking at sort of a full-blown non-admin support for MTC a while back, and a lot of progress was made in that direction. But we ended up, sort of the Experian event occurred, and we switched gears in order to make sure that we were hardened and ready for all of the upcoming migrations that are going on, making other improvements. So that was, the non-admin work was sort of deprioritized. And although there's still an interest in this, particularly in OSD, so we've been exploring deploying Valero in a namespaced manner so that we can actually run migrations in kind of a degraded way. So that some features we're not able to do, but it can still provide some value in a non-admin way. So here's a POC that Sean and Jason have been looking at, working on in order to achieve that.
Can you see my screen by any chance, or no?
Actually, it doesn't look like anyone's sharing to me. Sean, oh, there it goes.
Okay, well, this isn't really what I want to. Okay, that's fine. Give me 1 second. Okay, so for this demo, I just, in the interest of time, I've kind of set it all up beforehand, so it's not really like a live demo, but here I just was showing you that we're running Velero in OpenShift 3. One of the things that I had to do was set up this CR to give access to the Velero service account to all of the Velero resources. So here I wanted to show that we are the only role bindings for the Velero service account are these namespaced role bindings, and there's no cluster role bindings. So everything, all the permissions will be namespaced to the Nginx example namespace. So if we continue on here, we can see that the backup was completed a while ago. This is a backup that Jason ran when we got it working. So you can see Nginx stateless JSON 11. So now I'm going to go to my core cluster, and to do this work, we have to pre-create the namespace on the for cluster. So here I've created Nginx example, and I've also added the example role, the same one that was on the other one. So this is to the Velero resources. And here I'm also showing that for the role bindings, we only have role bindings for the admin role in Nginx example, as well as the testing role in Nginx example as well. So it's completely namespaced. It's not, there's no cluster role bindings for the Velero service account. So another piece of this, sorry, go back a second, is that the user will have to set up their backup storage location inside of the Nginx namespace. Because Velero is only watching that namespace, they'll have to set up their storage locations and the credentials and everything else that they need to set up to do a Velero restore on the for cluster. So we go here, this shows you the restore that I'm going to be creating. It's a simple restore. As you can see, we're not really removing a ton of stuff. It's pretty simple. Restore PVs, this is a stateless app, so that's not really going to do anything, but just a heads up that this is a stateless app. There is no state when it comes to this app. And here we can watch the Velero pod complete the restore. And then we can go to the restore itself and see that it partially failed. So I kind of want to talk about these partial failures. This is Velero by itself running against OpenShift, which means there's a lot of OpenShift specific things that end up failing on the restore, mostly around permissions and GIDs and the group IDs and some other stuff like that, because of the way that OpenShift does namespaces / projects and everything else. So we do need to probably get this running with the OpenShift plugin to do this, but I imagine that would fix those problems. It seems to be like problems that we would have already ran into. And then this is just showing you that the Nginx example is running in that 4 cluster. The stateless app was migrated. So yeah, that's pretty much all I wanted to show. Are there any questions?
Awesome. Thank you, Sean. Up next is Derek with on-demand rollback via the API. So we've been doing a lot of work around performing rollback of migrations. So there's definitely interest in doing things like dry runs, executing a migration that doesn't necessarily quiesce your source application, and then rolling back after you've confirmed and verified your target deployment, as well as rolling back in case of emergency. Previously we had this and it was automatic, and that was causing some problems for folks. So we're interested in making that a triggerable feature and exposing that to the user via the UI. And today we're going to be showing the API component of that. And up next, or the next piece of that we'll be adding during this sprint is actually exposing this via the UI. Derek?
Thanks, Eric. So I've tested this feature of BlueJeans that allows me to hook the audio from my computer into the output. So you guys let me know if you don't hear anything in like the first 10 seconds, but I'm going to use the audio track from this video. So I'm going to start it now.
Migration Toolkit for Containers 1.4. We've done some work to enhance the rollback experience when something goes wrong with your migration. And we've also spent some time trying to make it easier to recover from a failed migration, reducing the cleanup that you have to do before making your next migration attempt. Let's take a look at these new features by doing a sample migration and simulating a failure, running another migration that will automatically clean up from that failure. Finally, we'll roll back the completed migration and then run it all again. So we have a plan here that is going to migrate a namespace called Nginx Persistent Volume 30. There's 34 resources and 2 PVCs in this namespace, and I'm going to go ahead and click the migrate button. To simulate a situation where the migration perhaps gets stuck and needs to be deleted manually, I'm just deleting the migration here in the middle of the process, and we'll see how that gets cleaned up automatically on the next migration attempt. This is a pretty typical case that you might see if you were to have to abort a migration during the Valero restore. So you can see we have this stage pod running here. We have a stage pod on our source cluster, and our actual application is quiesced, meaning that it's not running on the source cluster. So to deal with this, let's actually, now that I've deleted the MIG migration, I can go back to the web UI and I can hit the migrate button again. And because of the changes that we've implemented in MTC 1.4, the stage pods will automatically be cleaned up and the application will automatically be unquiesced when it lands on the destination cluster. This is another change. We delete any incomplete Valero backups and restores that were created by past migration attempts. And if we need to, we'll restart the Valero pods. So here you can see that we are automatically terminating any leftover stage pods. This is one of the cleanup mechanisms that's needed for the next migration attempt to be successful. And now you can see that the stage pods have been deleted on this end, and the stage pod is gone on this end as well. One of the scenarios that we handle in MTC 1.4 that we didn't handle before was a case where the first migration attempt fails and leaves your applications quiesced on the source cluster. In this case, we need to make sure that the application is started back up when it lands on the destination cluster, or that it's made available again after a rollback is performed. So right here, what we'll see is that even though the app was at 0 replicas when we started this migration, the second attempt, it's going to get restored to its original replica count on the destination cluster after restore is complete. So we can notice that the app that got restored to our target cluster has 0 replicas when it lands there, but the new unquiesced destination applications step handles this, and you can see that now the deployment has been scaled back up to its original replica count. This way, your app is always running the way it was on the source cluster when it lands on the destination. So now that this second migration attempt has succeeded, we're going to perform a rollback migration that's going to remove everything that's been migrated by this migration plan so far and put it back the way it was on the source cluster before this plan started doing any work. See that the migrated application is being deleted, and we have our pod terminating here. Now that everything is removed from this namespace on the destination, the last thing we'll look for is the original replica count being restored on the source cluster. And here we can see that the original replica count is restored on the source cluster, and now the app is just like it was before we started doing any work. The next thing we'll do is delete all of our migrations, and we're going to start fresh again, just showing that you can migrate, roll back, and migrate again all day long. This is a little bit sped up, but as you can see, the end result is a completed migration, and your app is safely on the destination cluster.
Cool, so that's all we got for that demo. Did I head right back into the second one, Eric?
Yeah, sure, unless there's any questions.
Oh yeah,
I just want to say, Derek, that was pretty cool. Also, like the way you're able to get the audio to play.
Yeah, it's nice. They added a new feature in BlueJeans that installs an audio driver that pipes whatever's coming out of your system audio into the, I guess, the screen share. So pretty cool.
Yeah.
Yeah. So any other questions on that real quick?
Yes, I have a question.
Sure.
When we restore the original application, are we able to restore the number of pods that the deployment had deployed? So
yes, we can.
If I scale to 3 pods, for instance, then I migrate, I roll back, and I restore. Then I will get my 3 pods, my 3 original pods, not 1 but 3, right?
That is correct. We actually store the original replica count in an annotation so that we can reference that during the rollback. And we also use that same replica count in the case that your app is quiesced in that failure case I showed. So we always try to put your app at the exact same replica count that it was at before the migration started.
Okay, that's good. Thank you. Thank you very much. Good.
Yep. So the next demo here, I know we're a little over time, so I'll try to get us wrapped up. The next demo here is showing some performance and scale improvements in MTC 1.4. The driving idea here was try to make it so that a user can set up all of the migration plans that they want to run for migrating an entire cluster worth of applications and allow the user to leave those idle. In the past, that caused some severe performance problems, which you'll see in this video. And it had a huge impact on migration time if you set up a ton of migration plans, before you were ready to run your migration. So I'll kick it off.
This video, I'm going to go over some performance enhancements we've made to the migration toolkit for containers version 1.4. To begin, let's look at this metric screen where we can see a migration on the new version of MTC compared with a migration on the old version of MTC of the exact same app. You can see that it took 10 times longer to migrate the app with the previous version in a stress test cluster environment. To set up the stress test for this video, I created 60 migration plans. These migration plans all take a little bit of time to get ready, but once they are ready, we shouldn't need to do further validation on them until it's time to run the migration. This is one of the changes we've made in Migration Toolkit to Containers 1.4. Now that all of these plans are ready to go, I'm going to go ahead and run the first stress test. And first,
I'm just going to pause here real quick. To simulate this, what I did is I created 60 migration plans that are all pointed at different namespaces. And then I simulated a customer cluster that might have activity going on. So I used this kubecong operator to create 500 secrets. And then kubecong actually makes updates to those secrets on a regular interval, which sort of perhaps simulates if someone was just using their cluster as usual and there were different resources getting updated. In the previous version of MTC, we actually reconciled in response to almost every event on the cluster just because we were watching so many different types of resources. So that is just an explanation of why I set up the stress test in this way. And you can kind of understand if we were reconciling that much before in response to everything, that's why there was such a dramatic performance
we're going to look at the post-performance enhancement version. So if we find our first plan here and we hit the migrate button on it, we're going to see that a full migration of this app that contains Nginx and a single persistent volume claim will take around 4 minutes to complete. I sped the video up here to show this. One of the performance enhancements with MTC 1.4 is that we no longer create migration registries as soon as the plan is created. Instead, we wait for the migration to start to create these registries. And this means that if you need to plan out an entire cluster worth of migrations, you can set up all the plans ahead of time and let them idle without any consequence. I've sped the video up here once again just to show the whole process running. This took around 4 minutes total. 4 minutes and 18 seconds to be exact after performance enhancements with 60 migration plans. Now when we jump over to some metrics and we look at the amount of memory consumed by the migration controller, we can see that we're using around 67 megabytes of memory for the CAM container, which contains the migration controller. And this hovers around that region for the entirety of the migration. So it's very stable in that sense within this test. When we look at the Prometheus metrics that we have coming out of the controller, we can see that there was an initial spike of requests sent off while reconciling all of the plans and getting them ready, but the actual migration took around 2,000 requests to complete in total. Now, if we look at MTC 1.3 before these performance enhancements were applied, the first thing we'll notice is that as soon as the controller is started up, we're going to end up with 60 registry pods on each of our clusters, just because we have 60 migration plans that are sitting there idling. These registry pods aren't really going to be used before the migration, so it's a little wasteful. I've skipped ahead here to where the registries are all started, and we're running our second migration plan. And because of a lot of factors, one of those big factors being the remote watch system, even though this was massively sped up, you can see that this migration actually took 38 minutes to complete, compared to 4 minutes for MTC 1.4, which is about 9.5 times slower. And we can see that again here looking at the metrics. So you can see that's the first migration runtime, and then the second line here represents the runtime of the second migration. When we look at some other metrics that we have for this second migration on the older version of MTC, we notice that it uses 3 times the memory consumption compared to the new optimized version. And we can also see a pretty big difference if we look in the region where the migration was actually running. There were about 2,000 requests in the optimized version versus around 20,000 for the unoptimized MTC 1.3 release. And we also noticed that there's an ability in the new version of MTC for the controller to go almost completely idle when it's not doing work. You can see how it flatlines in the middle, but between startup after it's completed the initial reconcile and then before the first migration happens. And then once the migration is complete, you can see it flatlines once again, meaning that it's sort of truly idling, which is a good thing in terms of making sure that your cluster doesn't get overloaded. One of the biggest focuses with MTC 1.4 was to make sure that this tool will work even on the largest clusters with the most activity. So hopefully these changes will help you do migrations on that type of cluster.
Cool. So that's it. Any questions on that demo?
That's awesome, Derek. Thank you.
Good thing.
Cool. I think that wraps up MTC. So obviously we're over time quite a bit, but we've also extended this to a 90-minute review. Next up is solution integration. Brett, did you have anything that you wanted to show for this one? I don't know if Brett's on the call still. John, do you know if we were expecting anything for that? I think John dropped too. We had some folks, there's an IBM meeting that's going on currently, so I think a lot of people dropped to attend that meeting. So unless somebody's on the call that wants to present something for solution integration, I think we can probably wrap it up here. Okay. Thank you, everybody.